Wait, okay, I think I know how to do this.
Oh, I know how to do it.
Yeah, so you just connect it to one.
These are called Lewis dot structures, and you guys are doing a really nice job of seeing how these hook together. So, if you write them out correctly, I noticed there was a few people that did not write them out correctly, and at that point in time it will be a struggle. Because this puzzle, if you don't write the puzzle pieces out right, then you can't see how they fit together. So there is that one, so you'll put one here, and then one here, and then one here. So, that is PBr3. We just use a subscript to say how many we have. This is good old H2O. Water. So we know that oxygen's like that. Now here's hydrogen. It comes in, fills in. And that's what we have with water. So that's H2O. Okay, so that's a molecule. All these are molecules. Okay, that we're drawing. Molecules are basically a unit that represents a compound. And so this is a unit of H2O that represents the molecular structure of water. And then Si, you want to do Si and carbon like this. You want them all single. What happens? It becomes what's called a hybrid. Don't worry about hybrid, but what it does is it's a little different than the other ones the way you draw them. So then fluorine has its 7, and so it fills in here. Now I'm going to show you here in a second a simple way to show this without showing all these dots. So once we do this, with all these dots, we want to clean it up a little bit so it's not so...
I just added one dot.
So much going on. So that's SiF4, right?
Yeah.
Now here's how you clean it up to where it makes more sense, and you've probably seen this before in the biology textbook, especially with water. You've probably seen water written like this.
Oh, yeah.
Right?
A little bit. We saw that last year.
Yeah, we had to do that last year.
Okay? And then this one, just wherever you have a sharing of one pair, you just draw a line that represents that bond. So PBr, PBr, PBr. Okay? And then SiF4, again, it really cleans that one up. So it's just like this is that one there. And we don't show the dots that aren't involved in bonding. And so that's kind of way you would show those. Okay? So we have come a long way just in a short period of time of being able to draw these. This is a big part of molecular chemistry and being able to draw those out. We haven't really drawn any double or triple bonds, but if you can get this, then that transition won't be very, very tough. So, at this time, we'll have you turn over your periodic table and we'll look at this idea called electronegativity. Alright, so I'm going to give you 3 things that you're going to basically probably have to memorize, and it's not that difficult. It's 3 different types of bonding. So we can have these covalent bonds, but there's 2 different types of covalent bonds. There's only 2 different types of covalent bonds that we deal with. Okay? So, under covalent bond, there's 2 types. Okay? There's nonpolar covalent, and there's polar covalent. So, the words polar and nonpolar, can you guys, first of all, polar what does that mean to you? Something's polar.
North
Opposites. Good. Polar are opposites. And nonpolar, which means we're not going to have any difference. No difference. So you think polar are going to create where you've got opposites of one another, and nonpolar would represent that they're pretty much the same. All right, so we're going to use this number, electronegativity. Some of you guys did your board on electronegativity, and you said as you go across, electronegativity increases. Okay, until you get to the noble gases, and there's no bonding. And then as you go down, electronegativity decreases. So across it increases, going down it decreases. Okay? So nonpolar covalent, we're going to look at difference in electronegativity between the two bonded atoms would be 0 to 0.3. So I'm just going to put difference in electronegativity of 0 to 0.3. Okay, you're gonna be able to understand that here in a second after we do a couple. Okay. Polar covalent has a bigger difference in electronegativity. So I'm going to go ahead and just put quotes because I don't want to write that again. And it's going to be 0.4 to 1.8. Okay? So difference of 0 to 0.3 is going to be nonpolar covalent. Okay? So you're saying, well, that creates a different type of compound that has different characteristics than something that's polar covalent. Okay? Now, you'll understand what this means, this difference here in a second, because I'm going to give you some examples. Okay? The third one we've already discussed, and so I'm going to have you write a third one down, and this is the one we called Ionic. Remember we said that was probably between a metal and a nonmetal. Okay? So on that one, it's going to be a difference of electronegativity of greater than 1.8. Okay? So if it's ionic bond, the difference between the two bonded atoms is going to have a difference of 1.8 or greater. Okay, so we'll look at this again real quick. I'll go back to that slide. Covalent bonds that are nonpolar will have no difference in their electronegativity, basically. We say there's very little difference in their sharing of electrons. Okay? Very little difference. They share the electron pretty much equally. So if they share the electron equally, there's going to be no difference in the charges on the two atoms that are sharing electrons. If it's polar covalent, we say that there's a bigger difference, and because of that bigger difference, we have a bigger share. One of them has a bigger share of the electrons versus the other, due to the location of the electrons to one atom versus the other. And in this one, we say the difference is so big, there's actually a transfer of the electron. We say the difference is way too large and too big, then we really don't even call that sharing anymore. We call that a transfer because the difference is way too big. Okay? So I'm going to give you an analogy here real quick. I think it'll work. So you got to look up their electronegativities and subtract them. That's all you do. And if it falls between 0 and 0.3, it's nonpolar. If it falls between 0.3 or 0.4 and 1.8, what is it?
It's polar. 0.4. It's polar.
Okay, so what is phosphorus? Tell me.
2.19.
2.19. And bromine is
2.96.
2 point what?
96.
Okay? So that difference is going to be, what, 0.77?
Yeah.
So you subtract the 2 and it's a 0.77 difference. It's not negative or positive, so it's kind of like the absolute value difference. So that's polar covalent. So what does that mean, polar covalent? So I got P and Br here. This is the way you would show polar covalent. Okay? There's 2 different ways. This is the way I'm going to show you. Which one has a bigger share of the electrons? Bromine or phosphorus?
Bromine.
Okay, so we show an arrow going this way, so in that side's more polar. Bromine's more polar. Right? This side over here is negative. Okay, this side's going to be slightly negative. I'm going to put a little negative there. And this side's slightly positive.
So the side that's less is...
So the side that's less has less of a share of negative particles. The side that has a number bigger has a bigger share of negative particles. So if I have a bigger share of negative particles, then I'm going to be slightly negative. And the other side, since it has less of a share of those, it's going to end up on the positive side.
And they're polar, right?
And they're polar.
Okay.
Polar. Okay? So I'm going to give you another couple examples, and then you tell me what they would be, polar, nonpolar, or ionic in nature. Okay? And you always have this periodic table to look at, define these. And so I'm going to go ahead and give you one here. We're going to go ahead and say sulfur and selenium. So, if it's nonpolar, you do not draw an arrow because there's no difference. So, sulfur is 2.58,
Yeah, it is.
and then selenium is 2.55. We say they have equal shares. So, if we subtract the 2, take the absolute value of it, we get 0.03, and that would be nonpolar. We do not show arrows because the only reason we show arrow is to show that one side has a negative charge, and the other side's a positive charge. So this is polar. This example is polar.
So when it's polar, we have to show an arrow?
Yes.
What if it's ionic?
Ionic, you don't show an arrow either.
So just polar.
You just say ionic.
So the
Because it's actually a whole transfer. So let me give you one that would be ionic. You already know that. So I'm going to take K and put it with N. So that's a metal, K. And that's a nonmetal, N. So 90% of the time, they're going to end up to be ionic. Okay? So K is 0.82. Nitrogen is 3.04. Okay, and the difference is between the two is what? 2.22? This is ionic. So now, what we'll do on Friday, you guys get an opportunity to do compounds like A through E, and you're going to go through a series of tests to determine characteristics of polar, nonpolar, and ionic. And you'll be able to tell which compound's ionic, which compound's polar, and which one's nonpolar. Okay? All right, so I'm going to give you this assignment. It's going to be like yesterday's assignment or the day before's assignment. And it won't take you long to do these because they're real simple. So what you're going to do is page 296. And you're going to do 24 through 32 even. So why don't you turn that page real quick. I know we're running out of time. So this is truly homework. Because you'll have to do it out of class. Okay, turn to page 296. The first question's asking you, the first series of questions, 24, 26, and 28, or I'm sorry, 24 and 28, are asking you to do the trend, increase or decrease. So if it's going across, it's increasing. It's going down, it's decreasing. So that should be really easy to do, because that's what we did last chapter. 26 is super easy. And then 30 and 32 is what we just did here. Predict the following bonds as nonpolar, covalent, polar covalent, and ionic. And if it's polar covalent, I want you to show the arrow. If it's polar covalent, I want you to show the arrow.
Is this gonna be, like, is this stuff gonna be on our,
Going across, increases, going down,
Yes,
decreases.
This is gonna be
is this
on
gonna
our
be on our
final.
final? This stuff?
There'll be portions of it because we won't have a test strictly on just this stuff. Yeah. It'll be like 10% or 15% of your semester final.
What will be like the main,
Just put it in top tray.
what, like, will there be like anything that's like a super, like, a part of our grade, like, that will be?
Say that